All right, hello and welcome everyone to probability. Now, our very first lesson is going to be on Venn diagrams. So, if you're a little bit unsure about what mutually exclusive data is, what non mutually exclusive data is, what a set of data is, or what the intersection or union of a set of data is, then this is going to be a really good lesson for you. So make sure you listen through, follow along as best you can. I'd encourage you to have your maths books with you so you can pause the video and get the notes in as required. And, if you want to have a go at the questions before I do them, just so you can check, if you're feeling confident. All right, so let's just get onto it. So firstly, what is a Venn diagram? So it's used to graphically represent or display non-mutually exclusive data. So I guess the first thing is there's a big term there. What is non-mutually exclusive data? Well, I guess if you were doing a survey, and let's say you were surveying people on different ice cream flavors. And if you gave them a range of different ice cream flavors, let's say chocolate, strawberry, vanilla, I'll go basic and plain. And you said to them, okay, pick your favorite. They could only choose one of them. That's what we call mutually exclusive data, right? They can only pick one of them. They may enjoy all three of them, but in this situation, you're asking them to pick their favorite. That would be mutually exclusive. Non-mutually exclusive is actually what happens more often in the real world, where you're asking people, okay, well, do you like chocolate? Do you like strawberry? Or do you like vanilla? Right? They may like all three of them. They may like two of them. They may not like any of them. And they're free to choose the ones they like, the ones they don't like. So you may actually get a person liking more than one or choosing more than one. So that's what non-mutually exclusive data is. And that is going to be the main focus of this lesson here. So let's look at an example. Here we have some students that were surveyed about what social media they use. So we've got Instagram, TikTok, and Snapchat. By the way, this is a Venn diagram. See the big rectangle there? All the data that was collected, so every single student that was surveyed has been placed inside the rectangle. So the rectangle will contain all the data. Now these circles are what can be referred to as sets. If you look at the Instagram set, or the Insta, that's the top left one, every single kid that uses Instagram is contained within that circle. So that's the Instagram set of data. And of course, TikTok, it has its own circle. That's a set of data as well. If a student uses TikTok, they're in that TikTok circle, and likewise with Snapchat. You may notice that there's a random 2 down in the bottom right-hand corner. It's inside the rectangle, so it means it's part of the students that were surveyed, right? That 2 there represents 2 students that were surveyed, but they don't belong to either the Insta set, the TikTok, or the Snapchat set, or like circles. So they were students that were surveyed, but they happen to use neither of those 3 social media platforms. All right, so if we have a look at the first question, how many students, in total, I guess they're referring to how many students were surveyed. So in this case, all we really need to do is just add up all the students, right? So I'm going to start off. In the Insta, we had 4, 4, 7, 3. So we've got 18 there. Then there's another 2, that's 20, 28. We ended up with 30. That's actually a coincidence. I didn't mean for it to come out to be a nice sort of typical class size number. But if my additions were accurate there, we've got 30 students in total that were surveyed. Now, part B, which platform was most popular? Right, so in this particular case, they're just asking us, hey, of the 3 platforms, which was the most popular? So you may notice that some of these numbers, so when we add them up, you may notice some of these numbers, for example, that 7 right in the middle, it belongs to more than one circle. in actual fact, that 7 belongs to all 3 of them, right? If you look at that Instagram circle, here it is, right? That 7 is inside that Instagram circle. If you look at the TikTok circle, likewise, that 7's in the TikTok circle. And if you look at the Snapchat circle, bang, look at that 7's in there as well, right? What that 7 refers to is there were 7 students that used all 3 platforms, right? And likewise, with some of those other numbers in the middle, they may belong to a couple of the circles, but not the third. And, some of the numbers only belong to one number. So, for example, this 4 over here, that was 4 students that only use Instagram, right? So they weren't a part of the TikTok set of data, and they weren't a part of the Snapchat set of data. So that's what the numbers mean. So when we're trying to work out which platform is most popular, right, you can't just add up and see, which of these numbers is the largest. Because if you look at that, you say, well, Snapchat, there's 5 there in the Snapchat circle, which is larger than the Insta or TikTok. But we know there was more than 4 people using Instagram. There was more than 3 people using TikTok. There was even more than 5 people using Snapchat. We need to work out how many students in total we're using each, and only then can we then determine the mode or the most popular platform. So the Instagram platform, so let's add up all of them. The 7 and the 3 make 10, add the 2 4s. Okay, so Instagram had 18 in total. If you look at the TikTok set of data, what is that? There's, 16 students that are using TikTok, and Snapchat, obviously I'm just using S here to designate Snapchat. We ended up with 17. Okay, so what was the most popular platform? Instagram was the most popular social media platform for this particular set of non-mutually exclusive data, right? Non-mutually exclusive because, again, students, you're not forced to only pick one and only ever use one. You're allowed to have multiple different platforms that you use, right? So this is a real world scenario where you end up with non-mutually exclusive data. Okay, part C and D, okay, I got lazy here, obviously. I did want to introduce this term. See that thing that looks like a really messy N with no little vertical line? That is not an N at all. That symbol, this here is what I'm talking about, is actually the symbol for the intersection of these 2 separate sets. So what this question is asking us, in not particularly many words at all, is what is the intersection, right, or the overlap of the Instagram and the Snapchat sets of data. So if we go back up to the Insta and the Snapchat, right, so the left and the bottom circles, we're trying to find the intersection or the crossover. In other words, how many students use both of these applications? And so what you would do is, when you look at it, you'd say, okay, well, how many students belong to both the Insta and the Snapchat circles? And, actually, I'll just use blue. It's these students here, right? So what are all the different numbers, the students that belong to the intersection of both the Insta and Snapchat unions? There was 3 and 7. There were, in this case, 10 students in total. The bottom question, which I was equally as lazy with, that symbol there stands for the union, the combination of both sets. So for this final one, we're after the union of the Instagram and Snapchat sets. So what's the combined total? So where part C is asking us how many students use both, part D is asking us, well, how many students used Instagram or Snapchat? they don't have to use both, but in total, how many students are using Instagram and or Snapchat? So this is where you go up and say, okay, well, we have, if you look at the Instagram circle, we had 18 there. And let's add on the extra Snapchat ones that aren't already counted. It's the extra 2 and the 5. So you end up with 25 in total. So those 25 students was the union of them both. Some people go a little crazy with the union and they say, like you may notice back up here for part B, we calculated how many students were using Instagram and how many people were using Snapchat. And they say, oh, well, if you want to know how many students were using Instagram or Snapchat, you just add the 18 and the 17 together, right? And you get the total. What is the problem with doing that? Is because technically from that Instagram 18, 10 of those students were using Snapchat as well. So if you were to just add the 18 and the 17 together, I'm referring to these, you're actually counting those 10 students twice, which is why you actually end up with 10 larger than what the actual answer should be. Hopefully that makes sense. But yeah, alternatively, to be sure of it, you can just go back in and just manually add up the total number of students that belong to both circles, right? So this U stands for the union, the combination. The upside down U or the N without the vertical line, that's the intersection. You're only talking about the overlap, the number of people that are using both or belong to both sets. And when I say people, like more generally, they use the word elements. How many elements are in this set? How many elements are in that set? So this intersection symbol would refer to how many distinct elements belong to both sets. And the union would represent how many elements are there in total in both sets. But of course, the elements in this context is students with their phones and their need for social validation. No offense, teenagers. All right, on to our final example for Venn diagram lesson. All right, here we go. We've got a group of 30 students. Again, I didn't realize the previous example was 30, but here we go. This one's kind of asking us to do it the other way around. We've got 30 students, and they were asked if they liked English, and they were also asked if they liked math. They weren't asked which is their favorite, right? Because if we did that, we would have ended up with mutually exclusive data. They could only choose one. Here, we have a much more lifelike scenario. There will be some people that like both. There'll be some people that only like one, and there'll be some people that don't like either of these subjects, right? This is the real world. This is what will happen. We're going to be collecting non-mutually exclusive data. And when I say we're going to be collecting, I've already collected it, as in I just made up some data right here on the left. Okay, so I've gone ahead and wink, wink, nod, nod, did a survey. I asked 30 students if they liked English. 16 people said yes. I then asked, how many people liked math. 14 people said yes to math. We lost out. And there was 5 people that didn't like either. Now, again, at this point, some people will add them together and say 16, 14, and 5. That gives you a total of 35. How is that possible? There was only 30 students that were surveyed. How can you get a total of 35? You only surveyed 30 people. And of course, a lot of you already understand because of what we've been talking about. There may have been some students that liked both, which is why we've ended up with 35 in total. Now, what we're going to do to start off this, and what is easily the hardest part of this question, and maybe the lesson, is filling out a Venn diagram ourselves, right? The first example is pretty easy. We're already given the Venn diagram, even though it had 3 different sets. This one has only 2 sets, but filling it out is certainly, I believe anyway, harder than just reading it. All right, but let's have a go at it anyway. We've got 30 students in total. The easiest number to place is the people that don't belong to either the English or the math set, right? There were 5 students. We had 30 in total, right? But 5 of them said they didn't like either. So where do we put them in our Venn diagram? Well, they don't belong in the English circle or set. They don't belong inside the maths one, but they were still part of the data. They were still surveyed, so they belong in the Venn diagram. So they need to be inside the rectangle, but they can't be inside a circle. So you can put that 5 anywhere you want inside the rectangle, as long as it's not inside a circle as well. So I'm just going to pick a random corner. This is the corner that's closest to my pen. So bang, I put the 5 there. Some people think it has to be put in a particular spot. It does not. As long as it's inside the rectangle, but outside the circles, you're kind of good. All right, so we've got 5 people covered already. We had 30 in total. We've already placed 5. How many are left, right? There's going to be 25 students left that need to be inside the circles, right? Because we've covered all the people that don't belong to a set. So 25 students need to fit inside the circles. Well, let's keep going across from left to right. Let's look at the English circle. Right, how many students picked English? Or how many students said they liked English? 16. So that English circle needs 16 students in total. We've got 25 left that need to go in the circles. So if 16 of them belong in the English circle, how much is going to be left over for this maths part? Right, so 25 need to be there in total, and we're putting 16 of them in the English circle, right? So 25 take away 16, that tells us that we're going to have 9 left over for here. If 16 of them belong in the English circle, and we need 25 in total, then obviously over here in the separate maths section, we need 9 because 16 and 9 make 25. But there's more than 9 people that liked maths, right? So if you look at how many students said they liked maths, there's 14 in total. If we've got 9 there, look at the entire maths circle. Where are we going to put the remaining 5 students? They obviously need to be inside the maths circle, but they don't belong in that part. Obviously, they're going to be here. We've managed to work out, without knowing, but we've managed to work out there's actually 5 students that liked both. And then from there, we can finish off the English circle pretty good. There were 16 students or elements that belonged in the English set. We've already got 5 of them placed. They were in the intersection part or the overlap. That means we've got 11 that are left over here. That's how you complete a Venn diagram. Once you have the Venn diagram, find in, any sort of probability type questions or just, counting up questions are pretty basic. Part A, what is the union of the English and maths set? So remember, the union is the combined. So it's asking us how many students liked English and or maths. And so in this particular case, we're just adding up all the people that belong to those 2 circles or those 2 sets. How many elements are in those 2 sets combined? And so we're just plussing some numbers together, and you end up with 25. Let's be honest. Part B, what is the intersection? By the way, bang, remember union is that symbol. Intersection is our next one. That's the upside down version of union. What is the intersection of the English and maths? So this is just how many students belong to both sets. And in this case, there was 5 students. I should be putting technically the units for these numbers. All right, part C. Let's actually get on to, we're within probability. I don't think we've done any actual probability questions so far. So let's fix that. A student is selected at random, right? We've got 30 students in total, right? One of them is just going to get randomly chosen. We want to find the probability that they liked English. How many students liked English? There was 16. There was 16 students that liked English out of a total of 30. That's a probability. Simplify it down if you so choose. You know, express it as a decimal percentage. It actually doesn't matter. However you choose to express that number is totally fine. That's the probability. The second one, what's the probability that this random person chosen liked English only? So we're only like, it's not do they like English, it's like did they only like English? So in this case, we need to exclude those 5 that also belonged to the maths set. We're after the ones that only belonged to English. So in this case, we're dealing with, there was 11 of them in total, 11 of them out of a total of 30. And the final question I could fit on the page is a intersection question, right? This is the overlap. We want to find the probability that this random person liked both English and math. They liked English and math. So this question's asking us for only the overlap, which happened to be 5 students out of a total of 30, right? That was the number right in the middle. Sometimes you get questions, they might ask you what's the probability that a student likes neither. That's going to be pretty basic. If ever you see a probability question where they have a line above, that means the opposite or the complement of. So that would then mean what's the probability we get a student that, check this, didn't like English. So you're referring to all the students or elements that don't belong to that set. If you were to apply the same thing to, this one down the bottom, what's the probability a person liked English and math? If you put that line above, it now reads, what's the probability that they didn't like English and math? So again, you're talking about the opposite of what was originally stated before the line was added. All right, I'm going to leave it there. It's already gone on for too long, to be honest. But yeah, if you needed to stop, rewind, look at and rewatch any parts again, feel free to. If you wanted to get these examples and notes into your books, that's encouraged, but it's not going to be enforced. Just pause the video where you needed to, go back, get it copied into your books. If you have any questions, leave them either here in the video on YouTube or back on Canvas, and I'll see them. All right, best of luck with everything, and I'll see you for the next one. Okay, bye.